Hello students, welcome back. Today we will solve the question paper of Unit Test 2 of Mathematics of Standard 11 that was taken on 27th August 2020. Okay, so let's start with question 1. Section A, question number 1. How many elements has power set of A if A is equal to sorry, it's not a null set, it's a singleton set having element 5. So number of elements in A, that is equal to 1. Okay, see, if it was A equal to 5, then number of elements of A will be equal to 0. It's a null set, but the element 5 is in this set, so it is having one element. So what is the number of element in power set of A? It consists of all the subsets, so total number of subsets 2 raised to n. Now what is n here? 1. Okay, so the answer is 2. So this is equal to 2. Clear? So this was about question number 1. Now let's move to the second question. Question number 2. If A is equal to 1, 2, 3, 4. See, this 3, 4 in a set, this is considered as a single element. 5, then dash is incorrect. Now see, 1 and 2, 1 belongs to A, 2 belongs to A, that means 1, 2, this set is subset of this set. Yes, so this is correct. Means I will cancel it because I need to find out incorrect. Second, 5, is this subset of A? Yeah, so this is also correct, so I will cancel it out. Clear? Third, 3, 4. Now see here, 3 and 4 in curly bracket is an element, not a set. Right? Now, when you compare an element and a set, then the symbol must be belongs to, not a subset. So this is incorrect. So I will make a tick. Okay? And 1 and 2, here comparison of two sets, so it would be subset, so it does not belong, so that is correct, so I will cancel it. Okay, so this was about question number 2. Now let's move to the next, that is question number 3. Question number 3, if there are m elements in A and n elements in B, then the number of relations from A to B. Now see, when I take R A to B, then the relations is, or relation R is subset of A cross B. Right? Now see, number of element in A is m. Number of element in B is n. So what is the number of element in A cross B? M into n, that is mn. So now the relation is subset of A cross B. So total how many subsets of A cross B? Okay, that will be the total number of relation. Clear? So what is the formula for subset, total subset 2 raised to n? So here will be 2 raised to, what is n? Mn. So this is total number of relation from A to B, that is equal to 2 raised to mn. Clear? So here the answer is A, 2 raised to mn. Yeah. So this was about question number 3. Now let's see question number 4. Question number 4, it is given set A, that is equal to 0, 1, 2, 3, 4 and 5. Okay, a relation R is defined from A to A. And the domain is x, x plus 4. So see here, x, here it will be x plus 4. Which value of x I can take? 0, 1, 2, 3, 4, 5. Right? The question is find the domain of R. Means which value of x I can take. At present, I can take the value of x from A. But let me check whether I can take all the value or not. If I take 0, 0 plus 4, 4. If I take 1, 1 plus 4, 5. If I take 2, 2 plus 4, 6. 3 plus 4, 7, 8 and 9. Now what is the codomain? Codomain is also A. So the value of x plus 4 must belong to A. But this does not belong. 6 does not belong. 7 does not belong. 8 and 9 does not belong. Okay. So these are the value which we cannot take in this relation. I cannot take 2, 6, 3, 7, 4, 6 and 5, 9. So now what is the relation? 0, 4, 1, 5. Now what is the domain? The first element in each ordered pair. So domain is 0 and 1. Okay, the codomain is A and the range is 4 and 5. But in this question only domain is asked, so it's 0, 1. Clear? I cannot take 2 in the domain, because if I take 2 in the domain, then the range has value 6 and that does not belong to me. So domain is 0, 1. Yeah. So this was about question number 4. Now let's move to the next. That is question 5. So let me write down here. Let me write down here the answer. Domain is equal to 0, 1. Okay. So you need to do all the complete method. Okay. Now let's see next fifth. Fifth, 10, 19 pi by 3. So how we are going to solve it? What is the denominator? 3. Okay, which is the multiple of 3 closer to 19? We know that 3 6 are 18 and 3 7s are 19. Which is closer? 18. So 6. So this I will write it down 10. 19 pi, that will be equal to, I got here 18. Sorry, 3 sevens are 21 here. My mistake. So here I will write down this as 18 pi plus pi upon 3. So 10, 18 by 3, that is 6 pi plus pi by 3. Now see, when I draw a unit circle, okay, on this side I get even pi, means 0 pi, 2 pi, 4 pi, 6 pi. So here it will be 6 pi plus pi by 3. So first see, 6 pi see. So I need not change it. Okay, 10 will be equal to 10. So it's 10 pi by 10. Now 6 pi plus. So plus I need to go in this way. So it is in first quadrant, right? In first quadrant 10 is positive. So this will be positive. Value pi by 3. 10 pi by 3 is 10, 60, and that is equal to root 3. Okay, so the answer here is root 3. Okay, so that was about question number 5. Now let's move to section B. Section B, question number 6. Let A equal to 2, 3 and B equal to x such that x is solution of x square plus 5x plus 6. Okay, so set A is already given, that is 2, 3. Now for set B, x square plus 5x plus 6 equal to 0. I need to split this middle term. So 3 2s are 6. So x plus 3, x plus 2. When you will factorize, finally you will get this thing. Okay. So here I will get x plus 3 equal to 0 or x plus 2 equal to 0. X equal to minus 3 or x equal to minus 2. तो सेट बी शू आयो -2 and -3. Clear? I got the value of set B as -2 and -3. Are A and B equal sets or disjoint sets? Clear? So see A and set B, there is nothing common. If I take A intersection B, this is equal to 5. When there is nothing common in two sets, that means they are disjoint sets. Therefore, A and B are disjoint sets. Okay. Clear? So this was about question number 6. Oh, now there is also an option. Okay, there is one more part. Now the optional question, nk is equal to kx such that x belong to n. So what will be n2? N2 will be equal to 2x. Okay, and what will be n3? N3 will be equal to 3x. Okay, now see, n2, sorry, I can write it on this way. 2x such that x belongs to n. So when I will write down this, it will be 2, when I take a value of n, x as 1, 2, 3, 4, 2, 4, 6, 8, not 9, 10, 12, 14, 16, 18, and so on. Right? Now n3, kx means 3x such that x belongs to n. So in this case, when I take the value of x belongs to n, that is 1, 2, 3, 4, 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6 are 18, and so on. Okay. Now see, when I take n2, okay, intersection n3. When I take n2 intersection n3, so what will be this? This will be equal to what is common? 6, 12, 18. So see, difference of 6. First is 6, then 12, then 18. Now these are the multiples of 6. So I can write it down as 6x such that x belongs to n, and this is equal to n6. Clear? So n2 intersection n3, this is equal to n6. Right? So this is correct. Clear? So this was about question number 6. Clear? Now let's move to the next, that is question number 7. Question number 7. Find the domain and range of a real function fx equal to square root of 16 minus x. Fx is equal to square root of 16 minus x square. Now you need to find out the domain and range. Now see, square root cannot be negative. So what does this mean? 16 minus x square must be greater than 0. So 16 must be greater than x square, or x square must be less than 16. So which are the value of x that you can take such that x square will be less than 16? See, the maximum value I can take it as plus 4, because 4 square is 16, right? Okay, sorry, here less than equal to, square root of negative is not possible, but of 0 it is possible. So this will be less than equal to 16. So maximum value of x is 4 and minimum value minus 4. When I take 0, 0 square is 0, less than 16, 1 square 1, less than 16, 2 square 4, less than 16, 3 square 9, less than 16, 4 square 16 equal to, I cannot go. And when I go in negative, minus 1 square 1, minus 2 square 4, minus 3 square 9, and minus 4 square 16. Okay, clear? So what is the domain? You can take any value between minus 4 and plus 4, and you can take even minus 1 plus 4. So I will write it down, close interval minus 4 to plus 4. This is the domain. Clear? And now see, when I take the range, if I need to find out the range, x and f of x means square root of 16 minus x square. I can take any value, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. I can even take between 1 and 2 means 1.5, 1.3, 1.4. Okay, but I have just taken the integers. So minus 4, 16, minus 3, 9. Sorry, my mistake. When I take minus 4, 16 minus 16, 0. When I take minus 3, 16 minus 9, 7. When I take minus 2, 16 minus 2, 16 minus 4. Right? 2 square is 4. So 16 minus 4, that will be equal to 12. Square root of 12. My mistake. When I take minus 1, 16 minus 1, that will be equal to square root of 16, and that is equal to, sorry, 16 minus 1, so 15, root 15. When I take 0, 16 minus 0, root 16, and it's root 4. Clear? Okay. Now see, it's real function, so I can take both the negative and positive. Plus minus, plus minus, plus minus, plus minus 4. When I take 1, again plus minus root 15. Okay, 2. When I take 2, plus minus root 12. 3 plus minus root 7. 4, 0. Yeah. So see, which is the minimum value? Okay, minimum value when I will take, sorry, max root 15 I got here, right? I can take here also 0. Okay, so see, when I will be closer to 0, okay, just see here you can see as you are going towards 0, the answer of the range increases. And again, when you go towards 4, the answer of the range decreases. If I take positive, if I take negative, it decreases and again it increases. So what I mean to say here, I mean to say here that the maximum value is plus 4 and minimum value is minus 4. Remember this, the maximum value it's plus root 15 and minimum, sorry, plus 4 and minimum value minus 4. So the range here will be equal to minus 4 to plus 4. Here, so this was about question number 7. Let's move to the next, that is question number 8. Question number 8, you have to find out value of sine 75. Sine 75, I can write down sine 75 degree as 45 degree plus 30 degree, that is sine 75. So I'll use the formula sine alpha plus beta, SCCS. Sine 45 degree cos 30 plus cos 45 degree sine 30. What is the value of sine 45? 1 by root 2 cos 30 root 3 by 2 plus sine 45, sorry, cos 45 1 by root 2 sine 30 1 by 2. So see, 2 root 2 2 root 2 LCM will be same, 2 root 2. Now here it will be root 3 plus 1. Here, so answer is root 3 plus 1 upon 2 root 2. Okay, so this was about question number 8. Now section C, 3-mark question. Question number 9. If U equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 means the universal set. Set A 2, 4, 6, 8 and set B 2, 3, 5, 7. You have to verify first. A union B complement equal to A complement intersection B complement. Okay, so question 9. Let's start with A LHS. LHS is equal to A union B complement. Okay, so what is A 2, 4, 6, 8 and B 2, 3, 5, 7? So what will be A union B? 2, 3, 4, 5, 6, 7, 8 and its complement. So U is 1, 2, 3, 4, 5, 6, 7, 8, 9 and from that I need to eliminate 2, 3, 4, 5, 6, 7, 8. So I will get 1 and 9. Okay, now let's see RHS. A complement intersection B complement. So A is 2, 4, 6, 8. So A complement will be 1, 3, 5, 7, 9. Intersection. B complement, right? So B is 2, 3, 5, 7, 9. So B complement will be 1, 4, 6, 8, 9. Now when I take intersection of these two sets, 1 is common, 9 is common. So it is 1 and 9. So from this I can say that A union B complement equal to A complement intersection B complement. Clear? So it is true. Okay. Now let's see the second part. Okay. In question paper it is printed A. Here it's B. Question number 9. B. What is LHS? A intersection B complement. So this is equal to what is A intersection B? What is common in A and B? 2. Only 2 is common in A and B. Okay. 2 complement. Complement. So from union universal set, I need to eliminate 2. So I'll get 1, 3, 4, 5, 6, 7, 8, 9. RHS. RHS is equal to A complement union B complement. Right? So this is equal to what is A complement? It's 1, 3, 5, 7, 9. Union. B complement, B is 2, 3, 5, 7. So B complement 1, 4, 6, 8, 9. When I will take union of this, I will get 1, 3, 4, 5, 6, 7, 8, 9. And here also this is same. So what does this imply? A intersection B complement equal to A complement union B complement. Right? Actually, this is the De Morgan's law. A and B both. Clear? This question A and B both are the parts of De Morgan's law. Clear? Okay, so that was about question number 9. Now let's move to the next, that is question 10. Question number 10. Now see, here it is given A equal to 1, 2, 0, minus 1 and set B 1, 3, minus 1, minus 8. And the function is from A to B. Okay, now what is the function given? Fx is equal to Px plus Q. Now what is F? Ordered pair 1, 1, ordered pair 2, 3, ordered pair 0, minus 1, and ordered pair minus 1, minus 3. Now remember, when you are writing in ordered pair means here if this here it is 1, so what does this mean? This is f of 1. This is 2, this is f of 2. So on. So what I can write down? F of 1 is equal to 1. What is the formula for fx? Px plus q. So this will be p into 1. P plus q equal to 1. Okay. Now second, f of 2 is 3. F of 2 is equal to 3. So using this p into 2. So 2p plus q equal to 3. So I got two equations. What I will use? I will use elimination. One equation 1, p plus q equal to 1. Equation 2, 2p plus q equal to 3. Okay, so minus 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 q will get cancelled. So p minus 2p minus p. And 1 minus 3 minus 2. So what does this implies? P is equal to 2. Okay, now putting p equal to 2 in 1. Equation 1. So what I will get? P plus 1 equal to, so 2 plus q, right? Putting in this equation, p is 2. So 2 plus q equal to 1. Okay. So q is equal to 1 minus 2 minus 1. Okay. So this is the answer. The value of p is 2 and the value of q is minus 1. Okay. So this was about question number 10. Now let's move to the next, that is question 11. Moving towards 11. Question 11. You have to prove cos 6x is equal to 32 cos raised to 6x minus 48 cos raised to 4x plus 18 cos square x minus 1. Okay, so let's start with LHS. LHS is equal to cos 6x. So I can write down this cos 6x as cos 3 into 2x. Like this. Now what is if I take this as theta? What is the value of cos 3 theta? It is 4 cos cube theta minus 3 cos theta. So this will be equal to 4 cos cube. What is theta? 2x minus 3 cos 2x. I will take cos 2x common. So cos 2x, I will get 4 cos square 2x minus 3. So cos 2x will be equal to 2 cos square x minus 1. See, I am using the formula of here cos 2 theta, taking x as theta, 2 cos square theta minus 1. Because I want my answer in cos, so I will use this formula. I will not use 1 minus 2 sine square theta. 4. Now cos 2x, it's square. So cos 2x, 2 cos x minus 1. Sorry, 2 cos square x. 2 cos square x minus 1 whole square minus 3, right? The formula for cos 2x is 2 cos square x minus 1. So this will be equal to 2 cos square x minus 1. 4 into, now a minus b whole square. A square, that is 4 cos raised to 4x. Plus minus 2ab, 2 into 1 into 2, 4 cos square x plus b square plus 1 minus 3. This will be equal to 2 cos square x minus 1. 4 into 4, 16 cos raised to 4x minus 4 fours again 16 cos square x. 4 into 1, 4 minus 3, so it will be plus 1. Here 4 ones are 4 minus 3 plus 1. So now let us multiply it. 2 cos square x into 16 cos raised to 4x, that is 16 to the 32, and cos square and cos raised to 4, so that will be 2 plus 4 cos raised to 6x. 2 cos square x minus 16 cos square x minus 16 to the 32 cos raised to 4x. 2 cos square x plus 1 plus 2 cos square x. Multiply minus 1 by this. So minus 1 into this, minus 16 cos raised to 4x minus 16 cos square x and minus 1. So this will be equal to 32 cos raised to 6x minus 32 cos raised to 4x minus 16 cos raised to 4x. So minus 48 cos raised to 4x plus 2 minus, sorry, here it will be minus minus plus. Minus 1 into minus 16 plus 16. So plus 2 plus 16 plus 18 cos square x minus 1. Okay, this is equal to RHS. So this was about question number 11. Clear? Now let's move to section D, that is for 5-mark question. Section D, 5-mark question. There are two questions. One is an option. The first will solve the first one. Cot x is equal to minus 3 by 4. X is in second quadrant. Then find sin x by 2, cos x by 2, tan x by 2. Now see, cot x is equal to, I will write down here A. Cot x is equal to minus 3 by 4. So remember, we had discussed this, that for this type, first you need to find out cos x. Okay, if you get cos x, you can find out cos x by 2 and sin x by 2. Okay, so first I will just form the triangle theta. Okay, 3 by 4, ignoring the negative sign, cos theta is equal to adjacent upon opposite or base upon perpendicular. Using this, I will get 5 triplet. Okay, so now cos x will be equal to 3 by 5 adjacent upon hypotenuse. Now, as it is in second quadrant, it will be minus. Okay, now the formula for cos x by 2, that will be equal to square root of 1 minus 1 plus cos x upon 2. How I reached to this formula? I was having the formula cos 2x equal to 2 cos square x minus 1. So cos 2x plus 1 equal to 2 cos square x. So what is cos square x? 1 plus cos 2x upon 2, and cos x is equal to 1 plus cos 2x upon 2 square. See what I did? I doubled the angle. So here also it's x by 2, I doubled the angle. Similarly, for sin x by 2, I will use 1 minus sin x upon 2. There I will use the formula of cos 2x equal to 1 minus 2 sin square x. Okay, but you can use this formula directly, no need to derive it. Okay, so I'm using this formula here. So let's put out the value, square root of 1 plus, so it's minus 3 by 5 upon 2. So this will be equal to square root of 5 minus 3 upon 5, and this 2. So square root of 5 minus 3, 2 by 10, 1 by 5. Clear? So cos x by 2 is equal to 1 upon root 5. Now I need to check whether it is plus or minus. Right? Now, so it's given that x is in second quadrant, means pi by 2 less than x less than pi. I want x by 2, divide by 2. So pi by 2 upon 2, pi by 4, x by 2 and pi by 2. So this shows that x by 2 is in first quadrant. Okay, in first quadrant it is positive. So cos x by 2, 1 by root 5. Now for sin x by 2, I will use the formula 1 minus cos x upon 2. Okay, so the value of 1, sorry, cos x 1 minus 3 by 5 plus 3 by 5 by 2. So this will be equal to square root of 5 plus 3, that is 5 plus 3 upon 5 into 2. Okay, so square root of 8 by 10. So 2 4s are 2 5s are. So sin x by 2, that will be equal to square root of 4 2 by root 5. Sin x by 2 is 2 by root 5, and cos x by 2 is 1 by root 5. Now tan x by 2, that will be equal to sin x by 2 upon cos x by 2. So this will be equal to 2 by root 5 upon 1 by root 5. So tan x by 2, that will be equal to, okay, so these are the value of cos x by 2, sin x by 2 and tan x by 2. Yeah, so this was about the first question of 12th. Now let's see the optional question. Now let's see the optional part. For that, LHS is b square minus c square upon a square sine 2a plus c square minus a square upon b square sine 2b plus a square minus b square upon c square sine 2c. Okay, so now see here we will use sine rule. Okay, in your NCERT textbook, in chapter number 3, this sine rule is not given in the chapter. In fact, it is given at the end of the textbook where there are additional parts of chapter 3. Okay, so see, first let me explain you what is sine rule. Now see, if I take this triangle inscribed in this circle, let this be center. Okay, then this is the radius r. Then the side exactly opposite to angle A is having the length small a, opposite to angle B is having small b, and opposite to angle C is having small c. So the sine rule is A by sine A equal to B by sine B equal to C by sine C, and that is equal to 2R. Instead of 2R, I can also write it down K because the radius will be constant. Okay, clear? If I find out the centroid of this triangle and through that I can draw the circle passes on this vertex is having radius R. So I can write down instead of A, what is A? The length of the side opposite to angle A. That is equal to 2R sine A. B equal to 2R sine B, and C equal to 2R sine C. Okay, so this concept we are going to use in this optional question of 5 marks. We are going to use sine rule. Okay, okay. Now if I take only this one part, b square minus c square upon a square into sine. Okay, so what will be instead of b I can use 2r sine a. Okay, b equal to 2r sine a, c equal to 2r sine c, and a equal to 2r sine a. Sorry, my mistake, 2r sine b here. So this will be equal to 2r sine b whole square, 4r square sine square b minus 4r square sine square c upon 4r square sine square a into sine 2. So this will be equal to, let's take 4r square common, sine square b minus sine square c upon 4r square sine square a. Instead of sine 2a, I can write it down 2 sine a cos a. Okay, so 4r square gets cancelled here, sine square a and sine a get cancelled. So now sine square b minus sine square c, we can use formula sine b plus c sine b minus c. This is the formula, sine alpha plus beta, sine alpha minus beta equal to sine square alpha minus sine square beta upon sine a. Here I will use this 2 and cos a. Okay, now see, as it is a triangle A, B, C, angle A plus angle B plus angle C, this will be equal to pi, right? So that implies B plus C equal to pi minus A, or A is equal to pi minus B plus C. Okay, so now carried forward here, I will get 2 sine. Instead of B plus C, I can write it down pi minus A. Sine B minus C as it is, and instead of cos A, I can write down cos pi minus B plus C upon sine A. Okay, so this will be equal to 2 sine pi minus A, pi shift, so it will be sine. Okay, and pi minus, so second quadrant sine is positive. Sine b minus c as it is. Cos pi shift as it is, pi shift, cos will be equal to cos b plus c. Okay, and pi minus, so second quadrant, in second quadrant it is negative, so it will be minus, so I'm putting here minus upon sine a. So sine a get cancelled. Okay, now let the minus sign as it is. 2sc, 2sc will be equal to s plus s, so sine, okay, b minus c plus b plus c. Okay, I will add this angle, so minus c minus c gets cancelled, so it will be 2b. Okay, plus, sorry, s, so plus sine b minus c minus b minus c, so it is minus 2c upon sine a has got cancelled, right? So this will be equal to minus sine 2b. Now in sine minus comes outside, so minus sine 2c. When I multiply this minus sign, I will get minus plus, so sine 2c minus sine 2b. Okay, so see, this is 1. So from 1, LHS is equal to, see, when it is b square minus c square upon a square sine 2a, it's sine 2c minus 2b, means here it is c plus sine 2c, minus here it is b minus sine 2b. Okay, we just need to exchange it. Now similarly plus, here it is c square minus a square, we'll use the same formula. Okay, but it will be now sine 2a minus sine 2c, sine 2a minus sine 2c, just like this. When I solve this, I got this sine 2c minus sine 2, sine 2c minus sine 2b, so sine 2a minus sine 2c, and here plus sine 2b minus sine 2a, sine 2b minus sine 2a. Okay, so what will happen? Plus sine 2c minus sine 2c, plus sine 2a minus sine 2a. Okay, plus sine 2b, it's not square, it's 2b. Sine 2. So minus sine 2b plus sine 2b. And that is equal to 0. And that is equal to, okay. So what I did, I just took one part of it, solved it, and used the similar results in second and third, and I got 0. This was about the second part of question number 12. Okay, students, so that was about the solution of unit test 2 subject mathematics standard 11. Okay, so that's it for today.